My name's Ella, and I work at Groundwork Rhode Island, which is a nonprofit here in Rhode Island, and our sort of mission is creating healthier and more resilient urban communities through environmental sustainability and economic opportunity. That's the sort of tagline. And yeah, we do that through a variety of different programs. We have youth employment programs in the summer and throughout the academic year, and they do various forms of environmental stewardship. They do a lot of free stewardship and other things. We have adult job training programs, training folks with various barriers to employment in green jobs industry. We have like a landscaping and green infrastructure program where they do all kinds of tree care, green infrastructure, bioswales, that kind of thing, all over, a lot in Providence, but all over the state. We have a composting program called Harvest Cycle, which is what I run. So Harvest Cycle is a community composting program, and we do bike-powered food scrap collection in Providence. So we use bicycles to go around to people's houses, mostly people's houses, a few small businesses, to collect their food scraps and bring them to a couple different places throughout the city and to turn them into compost. And this is sort of the main place where we do that. I guess one other part of Groundwork is we also have this community garden right here. So it sounds like a lot of you have experience with community gardens. So people, rent a plot for the season and can grow whatever they want. So you'll see all the different plots here. They all look a little bit different, everyone growing their different things. But yeah, this is also where we process our compost, over there where we'll go in a little bit. So like I said, we're community composters, which is a pretty important to our sort of like mission and ethos. And like what that means is we think of food scraps not just as a piece of waste to be like discarded and taken away and never thought of again, but rather as a resource that should be used and transformed and then reused as close to the source that it was generated as possible. So within the community and by the community. So that's our goal, is to sort of have that full cycle of people eating food, discarding what they don't eat, turning into compost, used to grow more food, sort of as close to home as possible is the goal. So Harvest Cycle right now has about 550 members, people whose food scraps we collect. And about half of them, we collect it from their house, and then the other half use one of our drop-off sites. So one of them is here actually, where people can bring their scraps to a sort of centralized location on their own schedule and drop it off. So a mix of ways to participate. And right now we have 2 bike haulers who go around and do the picking up, and we have 1 part-time staff member who also does a lot of the compost processing. So she works here a lot, and I'm the program coordinator, so I sort of make sure everything happens and do this kind of thing. So super excited that all of you are here. So I'm here to talk about composting, obviously. And I figured we would start with sort of like the benefits of composting and why we do it, in addition to the few things that I just said. And then we'll go back there and talk and like see the compost and touch it and all that kind of thing. There are a lot of reasons why I think composting is great, and hopefully you guys do too. The one big one is it keeps food and other organic material like, plant scraps and things like that out of the landfill. And that's good for several reasons. For one, about 1/3 of the material going into our landfill, so like the trash that, gets picked up from your curb every week or whatever goes to the landfill, about 1/3 of that on average throughout the whole city is compostable, which is a huge portion, right? That's like a third of your bin could be composted. And so it's taking up a lot of space in the landfill. And our landfill in Rhode Island, we only have one, and it is on track to be full in about like 10 or 15 years, which is very soon. And there's no plans for what's going to happen next. We'll probably have to be like put on trains and sent to Ohio or something, which seems silly and expensive. So it's very important to keep things that don't need to go into the landfill out. One reason. Also, when organic material like foods goes into the landfill, there's no oxygen. When they put stuff into the landfill, they seal it and it just stays there forever and ever, and nothing else goes in or out. And so when organic material is without oxygen, it releases methane, which some of you might know is a greenhouse gas, which contributes to climate change. And a big portion, I can't remember the exact amount, but a decent amount of the methane produced in the US or in the world comes from landfills, which is from organic material just rotting in there. And it's very smelly and bad for the environment. And if there's too much of it, it can even be bad for people's health and stuff. So lots of reasons to keep food out of the landfill. So those are sort of like, yeah, big picture reasons why we might want to do that, why we might want to rethink where we put our food scraps and organic materials, and then why we want to compost them. The finished product of compost also has a lot of benefits. One of them is it's very good for sort of protecting against flooding and erosion. Compost, like the finished compost product, can hold like 5 to 20 times its weight in water. So it's kind of like a sponge. It really absorbs a lot of water. And so if it's put in places that, you know, if there's like a sort of valley that's just a grass, that might flood a lot. If there's compost in that sort of landscaping, it will really help absorb that water. So yeah, that's one exciting potential use for compost. And then one that I'm sure you all are probably interested in is it's good for plants and for gardening. So it does a lot of things, and there's all kinds of research out there that you can get. You can read all scientific papers and stuff, and there's a lot of proven and well-studied benefits. But some sort of high-level things are it helps with pest control. Some studies say it sort of like helps plants produce kind of like not pest control, disease control, like sort of stimulates antibiotic properties. And various other biological chemical things that I don't really understand because I'm not a scientist, but someday I will be. But yeah, another thing is that it is really good for the soil. It helps hold water, so if it's really hot and dry out, it will help keep your plants, you know, nice and moist. It's very good for soil structure. It sort of, you know, allows the soil to be kind of light and not too compact, and, you know, leave room for roots and worms and bugs and stuff like that. And it adds a ton of nutrients, which is a huge one, because if you can imagine, we're making compost with food, which obviously we get all kinds of nutrients from, and those same nutrients are sort of being transformed a little bit, but they're still there, and they're into more plant available forms. So your plants can sort of reuse that and make more nutrient dense food. So those are some main reasons why. And then another big one, which is essential to the sort of community composting, is like a really powerful way to sort of build and create community. It's a very, like, you can do it alone, but also it's a way to sort of bring people together around this sort of like amazing transformative process. And so that's like also part of our goal, is like involving people like all of you and others in this process, where we can like witness this amazing transformation and watch things grow from the process. Let's go to the compost area. which is this way. So similar to us, they need water in order to do their work. I don't know exactly how it works in their bodies, but I know that they need it to sort of move around within the pile. So there needs to be enough moisture for them to sort of work properly. So that's sort of like, that's a recipe for happy, yes, please. Happy microbes in your compost pile, and that's sort of the environment that we're sort of creating. But obviously that's like chemistry, right? That's not like us working with our hands in the real world. So those things sort of translate into the other stuff that we're doing. So the carbon that we use, we call browns. That's just because they're usually brown. They're like wood chips and dried leaves and maybe sawdust or cardboard. Things like that are materials that are high in carbon, which is sort of the main thing that the microbes are trying to eat. Nitrogen, the nitrogen that we're mainly working with is food scrap. That's the material that is, and we call that, greens also. So our recipe is like browns and greens, and the greens are food scraps, but also if you were composting maybe manure, that would also be your sort of high nitrogen material, or, fresh garden trimmings like the tomato plant that you're just pulling up that's still green. Everything has its own sort of chemical formula, but in the big picture, those are your sort of green materials, and then oxygen and water stay the same. So yeah, that's the sort of recipe that we're going for, and there is an ideal sort of chemical ratio, but again, we can't see that or touch that. That's like something you'd have to measure in a lab, so we sort of break that into just like a volume ratio. So if you're like mixing up a pile, you might say, I want 1 tub of food scraps and I want 3 tubs of leaves. You sort of are just like making your ratio based on volume, and it's usually about 1 part greens to 3 parts brown. So if you had 1 bucket of food scraps from your week of collecting in your kitchen and you're putting it in a pile, you might mix that with 3 buckets of, leaves or wood chips or both. And everyone's kind of got their own recipe. Here we do more like 1 part food scraps and 1.5 parts brown material, just because that's what we found works for us, and we're so actively managing it that it's all right. It's a little bit of trial and error. You might do something, you might find it's super wet. You might do something and find that, it's super dry and nothing's happening. So it's a little bit of trial and error with educated guesses. Yeah, so we talked about oxygen, we talked about moisture. Those are key components. There are a couple other sort of important things that don't really fit into the formula but are important, and they're related to those things. So one is bulk density or porosity, which basically is just making sure that your pile is like a little bit fluffy and it's not just like fully compacted. And that's just to allow water and air to sort of move between your particles so that the microbes who are also moving between the particles can work properly. If a pile is too dense, meaning it's like super compacted, the microbes won't be able to live in there, right? And it might get anaerobic, which is bad, and smelly, and releases methane. I don't know if you've ever smelled, you've all probably smelled, we could smell it when I open up one of those cans over there. That sort of like very pungent, rotten, eggy smell that's the anaerobic decomposition, which we don't want. If you find that your pile is too dense and is maybe becoming anaerobic, there are ways to sort of remedy that. Mostly it means first you can sort of manually sort of turn it with a pitchfork, fluff it up a little bit, but you also might need to add things that might naturally add that sort of porosity. So the most common way to do that is adding wood chips. So you can imagine, and you can see in the piles, like a big piece of wood chips will naturally sort of create little pockets in the pile, and make sure things like, I don't know if you can imagine, like sawdust would very easily just like smush into just like a hard thing, versus if you've got big pieces, it won't do that. So yeah, having a sort of variety of pieces of things that are in your compost pile is very helpful to that, creating that ideal environment. So I thought you want a variety of particle sizes, but also you want, the smaller the pieces, the faster they'll break down, right? I don't know, I'm sure you can imagine having a whole apple and you like put that out in the forest or under the soil or whatever, and it might take a little while to break down versus 5 pieces this big. And that's just because the microbes are working on the surface of the particles, and I don't know if you remember from like high school geometry, surface area to volume ratio, versus, so if they're working along the whole surface and and your piece of material is mostly surface, they're going to work really fast. Yeah, so those are the main components. Hopefully it wasn't too nerdy and like in depth. And one last thing before we really get into the piles is temperature. So the microbes, again, similar to humans, when they're working hard, they produce heat. Similar to if we're like running or whatever, working very hard, gardening, we produce heat and sweat. And so the microbes in the pile are working very hard, digesting very hard, and they're producing heat and heating up the pile. But they're also maybe a little bit unlike us. In warmer environments, they work faster. And so it's kind of like they will produce heat, and thus everyone around them will work even harder and produce more heat. And so it's kind of like a snowball effect where they're just making more heat and working even harder. And that's very good for us. A sort of typical compost pile temperature sort of looks like this, where this is temperature and time. So during use whatever color you want. During the first, week or so, when the food is fresh, when all the nutrients are accessible, they will work very hard and heat up the pile really quick. And then they'll continue to work and keep breaking down, but maybe slower. They'll break down parts of the food that is harder to digest. Also, kind of like us, they do sugars and carbs, fat first and quicker. Just like us, that's where we get our quick energy. And then the other stuff later on, and with sort of different creatures are contributing at different times as well. There's lots of different bacteria and fungi, and they all sort of like their own type of nutrient and their own sort of temperature and environment. Yeah, I think that is sort of the gist of it. I guess I can just sort of put timeline on here, or every compost pile is going to have a sort of a different timeline, but in general, this hottest point will be within like 1 week or 10 days. Let's just put like 10 days. That first bit will be pretty quick. This bit will be like 2 to 6 or 8 weeks. Maybe we'll just put like 2 months. I don't know. And then this last phase is the longest one. It's not to scale, obviously. But that last one, it can be like maybe sort of a minimum of 2 or 3 months, but we sometimes leave it for like 6 to 12 months. It's kind of like the older, the better. it continues to break down. It's sort of the worms and little bugs, you know, eat stuff and poop out the good stuff that's good for our soil, and they're just sort of continuing to make it better and better. And so the older it is, the finer it will be, which is nice for little seedlings and stuff. And also basically the whole process from start to finish might take about 6 months and maybe even longer. Some composters won't even use or sell or give away compost that is less than a year old because they think, you know, they want it to be top quality. We can sort of, look in the piles if we want. So here, there are a lot of different ways to do the composting process. Here, I'll just mostly talk about ours because that's what I know the best. But I know a little bit about other things if people have questions about how to do it at home and stuff. But here we do, like, the material that's in one bin is sort of gets mixed together all at once and then lives as that batch for sort of its entire life. We are not like continually adding food scraps. If you're composting at home, you're probably adding food scraps maybe every week or however often you collect in your kitchen. But because we have so much all the time, we can sort of mix it all up at once and then put it in. So we sort of lay out a big tarp, mix our browns and greens. We take shovels and chop anything that's big. Sometimes people will put, you know, like a whole cabbage or something. And so we chop all that up to make it as small as possible, mix it, and then we put it in the bins. And it'll stay in these bins for like 6 to 12 weeks, which is sort of this first phase. During that time, we are also turning the pile, sort of like flipping it about once a week, which people remember why you might do that. To add oxygen is the main reason. When the things are working really hard, if there's a little microbe in the very middle of the pile, it works. It sort of uses all the oxygen it has in its area, and then it can't get any more because there's no like wind or anything going into there. So we will turn the pile and flip it in order to reintroduce oxygen to sort of, you know, give it a breath of fresh air, if you will. So we'll do that about once a week for at least the first month. And that also allows us to mix it up and make sure we don't have any pockets that are anaerobic, because we don't want that. We can look at some different ages of compost. These batches we started on Tuesday, so not long ago at all, just like 4 days ago. And it's a little bit deceptive. There's finished compost on top. It's quite hot in there. This temperature gauge is going up. It's at 140 degrees right now and still rising. I'm standing next to it and I can feel the heat coming off. And you can it's got a little bit of a smell right now, as you can probably see. You can also see just from Tuesday, like, it still sort of looks like food, right? This is like a lemon peel or something like that. It's really warm. So this far into the process, the microbes are working really hard and they're breaking down, you know, the stuff that is easiest for them to break down. We don't add any worms or anything. It's just leaves, wood chips, food scraps. And then the top layer is some finished compost. And we do that just because it's a nice odor cap. When we put that on the top, it keeps all the smells in, which is good for our friends on either side. So these white things, but there are these white bacteria that are very present in the beginning hot phase of the compost. They're called actinomycetes, if you want to get super scientific about it. But those are just a nice sort of visual way to look in your fresh pile, and you check the temperature. You're like, great, it's getting hot. You see those, you're like, great, the right bacteria are there. They're doing their thing, and sort of it looks kind of like ash sometimes even in there. It's like gray and a little bit flaky, but it's actually a good thing, which is nice. So it's good to see that. This one is not ready. This is only, well, this stuff would be ready, the stuff that I put on top, but it's sort of gonna get reused here. The other stuff is not ready. It's just 4 days old, so it has another year to go. You know, we'll probably turn this next week sometime after about 7 to 10, it having been doing its thing for 7 to 10 days, and at that point it doesn't really smell too much, so we don't need an odor cap. If it was for some reason wet and smelly, we would do it, but it doesn't usually need that. This one's probably like 4 or 5 weeks, maybe even a little bit more. And this is the gray stuff I was talking about, those good bacteria that you can see. Let me put the thermometer in there. Yeah, so it's like you can't even see the food anymore, right? Occasionally, like, I can tell this is an avocado skin, but barely, right? And so at that point, it doesn't, I think it smells good even. Anyone's welcome to smell it or touch it if you want. But yeah, it doesn't smell, it barely looks like food. Certain things are never gonna break down, like a peach pit. Well, it will eventually, but not in the 8 weeks that it's in here. And like eggshells, you probably saw in that bucket of finished compost, there's a lot of little bits of eggshells, but all the main, you know, juicy stuff that would smell and is full of nutrients is pretty much gone at this point. Yeah, and it's not really that hot anymore. It's still warm. It's at about 90 degrees Fahrenheit, so it's kind of in this phase where it's still warm, it's still, you know, breaking down fairly quickly, but it's not at that peak hot temperature. And one thing I also wanted to point out to you guys is if you want to look at these two and see if you notice, like, these two were started at the same time theoretically with the same batches, but to me they look kind of different. When it gets sort of flaky like that, the breaking down doesn't really happen because those microbes don't have the water that they need. I also haven't dug down deep. It might be wetter underneath and it just needs a stir. So these are like the kinds of things that if you are composting and you look at your pile, things you might want to notice, and then with some experience, once you start to notice them, you can start to correct any issues that they might have. I think I put some like yeah, like a few other things that you can check. So one of them is, yeah, sort of like feeling and looking at the moisture. This is like super flaky and crumbly. This stuff, if I grab it, it's still kind of big pieces, so it's not perfect, but if I grab it, it kind of like, that's a bad example, never mind. But you want it to kind of like stick together, which will only happen once your pieces are kind of small, but you want it to be not like dripping water, but not like flaky, crumbly like this, and sort of somewhere in between there is a good amount of moisture. Too wet is harder to correct than too dry, that's for sure. One thing that you could do is, if it's at like a later stage, like one of these, and it's not full of like kind of fresh food scraps, you could like spread it out if possible and sort of let it dry. If you are keeping it in a bin or you don't have space to do that or something, you can add more brown material. So you could add some wood chips or some leaves or some shredded cardboard or whatever to try to absorb some of that liquid. Yeah, those are, sawdust is like really good at absorbing liquid. Turning will also help just because it will like add more air. Too wet can be a challenge for sure. If you have an uncovered pile and it's already kind of like a really nice moisture, or it's already borderline maybe a little bit too wet, and you know we're about to get a big rainstorm, you might want to cover it with a tarp just in case. There's definitely like a decent amount of wiggle room. Like if this got rained on, it probably wouldn't be a problem. It's not like just because compost is so good at, you know, sort of absorbing and managing water on its own, but yeah, with some of the storms we've got lately and stuff, like you wouldn't want to leave one of those fresh piles uncovered probably, just because it might get really saturated and smelly. Yeah, one last sort of step of the process before we move on is, which is not super necessary if you're just doing this on your own and using it in your yard, but we sift the finished product, which we can maybe on our way back look at the sifter, but it's that sort of round wire thing over there, and that's just because even after 6 months or a year, there's still going to be some pieces that are this big. You know, when you're planting seedlings in the spring, they won't enjoy trying to work around big pieces of wood and stuff, and so we sift all the big pieces out and just sort of give back and use the finely sifted material, and then we'll use the stuff that we sift out as like mulch around trees or put it back in or something. So that's not super necessary if you're just making your own compost, and it doesn't really matter if you have some big pieces, but it's sort of like a best practice if you're selling or giving away compost. And compost that you buy in a bag from like a nursery will almost certainly have been sifted before that. So we do that like in the spring, sort of before and as we're giving back our finished compost. So yeah, I think I forgot to mention that.
Yes, I was just going to ask.
Yeah. Yeah, I forgot to mention that in the beginning, but the people whose food scraps we've collected have the option of receiving the finished product back in the spring if they want to use it. So it is that sort of same full circle situation. Not everyone wants it, not everyone has plants or a yard, but usually about 2/3 or so of people want at least some, and then a bunch of it gets used in this garden also by the community gardens and at some of our other gardens as well. The compost pile is actually not that attractive to pests. Some ways to sort of prevent them one is to keep open space around and between your bins and piles. Rodents really are afraid of open space. They like to be like covered by stuff or burrowing, and so having this open area, they won't want to get to the bin because they don't want to scurry across this big open space where they're afraid of a bird coming to get them or something. Another good thing is, if you can, I know it's not possible for many people, but composting on a hard surface like asphalt is also very helpful because nothing can burrow into it. And if you can't do that, or in addition, which is what we do here, is we have, like I said, the hardware cloth or the wire mesh on the bottom so that they can't chew through that and get into the bins. So that's good to do, you know, regardless, even if you're on just the grass or the ground, having that is helpful. Getting the right recipe, like I said, a well-managed and like actively going compost pile is not that appealing to them. And so if your recipe is right, if the decomposition is happening as it should, they won't be that interested. If you've got stuff that is sort of out in the open and smelling, or it's, too much food and not enough wood chips or brown materials, that's more interesting for them. So getting your recipe and your process right is possible. The compost pile is actually not that attractive to pests. We can look at the sifter when we go back past. We shaped them like this so that water will like fall on it, but it won't get too saturated. It kind of like will roll off the edge. It's like it's called a windrow. It's just another sort of like best management. Yeah, the piles are here, and these ones will sit here until the spring. They'll be here all winter. We'll add a little bit more, from what's back there now. But then once they're sort of ready to be sifted and given away, this is our sifter. It's overgrown by wild volunteer squash. We sort of shovel the stuff in this end, and someone is standing down here, and this spins like this, and the fine material will fall out the bottom, and then the big materials sort of come all the way out the end. We put like a tarp underneath to catch it. So it's a few people working at a time. Takes a long time, a lot of work, but it's also kind of fun. This is made out of bike rims, which is pretty fun. Our friend Rosie, who lives over there, built it, and that's just to keep. And so all of these like big pieces on the ground over here, these have all been sifted out. And then the finished material, yeah, we give away. And usually we have like a couple events here every spring where our subscribers will come and pick up their compost, and it's really fun. And I get to meet everyone who I've been emailing all year. So it's a good time. That is the sifter, the end of the process. Thanks for coming. And yeah, I know you had things to say.